Hello, everyone. My name is Louis Songwoo Cho. I'm an undergraduate senior majoring in civil engineering, specializing in transportation, and I'm also minoring in computer science at the University of Illinois at Urbana-Champaign. I am also the president of the Institute of Transportation Engineers, UIUC chapter, and today I will be doing a Python tutorial for everyone. To get us started, we're going to be dealing with some basic variable types and also some basic calculations. So write this down here. To store a value into a variable Python, all you gotta do is this, and we'll do addition here. And then if you want to do subtraction, this is how you do it. Multiplication. And we can also do division. Also, if you want to, let's say, do like an integer division. So if you don't want these like floating points at the end, all you got to do is do A, B. This is integer division. There, we get 1. And if we want to get the remainder, all you got to do is have a percentage sign here. There we go. Now let's say if you want to round to like certain number of decimal places, all you got to do is uh first divide, oops, and then let's say we want to round it to 2 decimal places, then you would call the round function like this. There we go. Also, I'll be teaching you how to format strings. So let's say my age is 22 years old. Comment to format strings. Let's say Lewis is 22 years old, and I want to format this a little carefully here. So what you do is print, okay? Press F. F means format, and a single colon. Lewis is, now you want to open up curly brackets here and then say age, space, years old. It's a little convenient here because you can actually mix the string and the numeric variables together when you actually want to print down to sentence. So, Shift Enter, boom, there you go. Let's do one more example. Name is equal to Louis Songwoo Cho. School is UIUC. And print name school. You can do this as well, but like in general, I recommend this one because like this one is just you have like 2 strings, and if you put a comma here, a space is automatically generated. Okay, guys? Any questions? Nope. Okay. Now we'll move on some like basic functions and data structures. I'm pretty sure you guys worked with lists. List is like a way to like efficiently store like each item. So I'll say let's create a Lewis list. You can name whatever list you want. So we'll initialize it with some empty stuff here. Obviously, there's nothing here. Now, if you want to like add each like element towards the end of the list, what you can do is Lewis list dot append. And then what happens is a 0 is appended here. Okay. How many of you heard of like for loops? like iterating through each like list, or like for a certain number of times I want to iterate through to like perform this function or some sort of a calculation. Okay, so I could say for I in range 10, and then Lewis list dot append I. Okay, and then what happens is for like 9, for like 10 number of times I've appended all my variables here. Also, here's a thing to watch out here. If you, let's say for I in range 10, the index goes up to from 0 to 9. It does not include the 10. Are we all clear with this? Because I know like some like coding exams, they'll ask you like how many, like what index does this for loop go up to? It's not 10, it's 9. Are we all clear with this? Okay. Now I want to remove the element at the 0th index. Let's do that. Dot pop 0. What we'll do is it'll remove the element at the 0th index. At the 0th index. So what this will happen is the element at the 0th index has been eliminated. Okay. And then if I want to remove the element at the index number 1, what I can do is this. Just copy and paste, and then boom, 1 is gone. Now I want to insert like an element at a certain position. So if that's the case, what I could do is dot insert 3. Let's say, oh, sorry. I want to insert 3 at position 5. So what I'll do is I'll say at position 5 or index 5, I want to insert the element 3. So what happens is here, 3 has been inserted at index number 5. Are we all clear with this? Now here's a fancy Python trick when you're also working with for loops. Let's say I want to print out the value and at the index at the same time simultaneously. This is another question like people have been asking how we can do this. If that's the case, I'll introduce a function called enumerate. So what we do is for key val and enumerate, let's say Lewis list. What we can do is print key and then value. See? So what the key is, it's telling you the index, and the value is what item with respect to that index is. Are we all clear with this? So you don't have to separately create like a separate counter variable and increment each time when you're like traversing the for loop. It gets annoying, so I'd rather do this. And also, if you want to sort your elements out, what you can do is sorted list is equal to sorted Lewis list. And then if we print out the sorted list, it's sorting in ascending order. And of course, let's do also Python has another data structure called tuples. Tuples is like a pair, or usually like to store like two variables and like tied together. However, here's the thing about tuples. They are not mutable, meaning that you cannot like change or add or delete an element to that data structure, unlike lists. So usually what happens is if I want to do tuples, I would just have to go like this. 1, oopsies, 2, b is equal to 3 comma 4. And then obviously, if I print this out, we can do that. However, like I said earlier, a dot append 3, this will not work because obviously tuples are immutable. You cannot change once you declare a tuple like this. Are we all clear with this? Okay. If we want to get the first element of a tuple, all we got to do is just do this. Are we all clear, or it's in terms of efficiency, when you have like really long, like really big amount of data that you need to actually like process through, let's say like when you're working with like a language classification and you have to like, let's say find like the pattern between like biograms, let's say 2 words, it's rather than doing a list, it's usually used for like some efficiency issues. For if you're taking like let's say an AI class, professors will try to encourage you to be efficient with your memory. So in general, it's recommended to use tuples in those cases. Yes? Sorry? To No. It's just like a data structure to store like a pair. Okay. And then we can also do this. Let's also continue on with the tuples. So top list. I want to print out, or let's say tuples. Okay, are we okay with here? Now, I want to, let's say, print out the index of the each list, and also, I also want to print out the items. So let's do it again for key, val, and enumerate. Oops. Top list. And print f tuple key. Okay. Boom. How does this look, guys? All good? Okay. Also, when you're how many of you are taking like Math 257, the linear algebra computational applications? You're gonna deal with a lot of matrices. So I'm going to like also emphasize like you will be working a lot with two-dimensional arrays. So let's say you want to construct like an matrix, let's say with certain number of rows and certain number of columns. If that's the case, all you gotta do is this. We'll declare how many rows we want, and we also need to declare how many columns we want. Okay, we're all good here, right? Now, matrix is equal to, are we okay with here? And what you got to do is, let's say I want to store like, let's say a dummy variable here for j in range calls. This will create like a column, and then I also want to make sure this is 2D like this, okay? So basically what we're trying to do here is create like a dummy matrix full of zeros. We want to have 3 rows and 2 columns. Are we clear with this? There we go. All good? And let's say we want to traverse and traverse 2D arrays in Python. So traverse 2D arrays in Python. So what we'll do is also be careful with this for loop here. Do you want to traverse each row? So like what you do is like when you're traversing matrices, what you can do is for each row, you want to go by each column, or for each column, you want to go by each row. I know this sounds confusing, but I'll explain to you what this process is. So let me open up my Zoom. So you're given, let's say, a matrix here, okay? Let's say I have 0, 1, 1, 3, 1, 0, 2, 0, 3, 5, 1, 2. Okay? Now, I'll show you a code. So what I'm trying to do is for I in range rows, for j in range calls, and let's say do something. Notice like I say for I in range rows in the outer for loop, and then the inner for loop I say for j in range calls. What this is doing is for each row, I'm going to go 1, 2, 3, 4. Okay? Does this make sense? And then once I do that, I go to the next row and then iterate through the same. 1, 2, 3, 4. Okay? Are we all clear with this? Now, if I flip this around, let's say for I in range calls, oopsies, for j in range rows, it will do the opposite. So basically what I'm going to do in this case is I'm going to go like, in the first column, I'm going to go 1, 2, 3. The next column, 1, 2, 3. This column, 1, 2, 3, and then so on. Are we all clear with this? When you're creating for loops, be careful of like what goes on the top and what goes on the bottom with the nested for loops. Are we all clear with this? Okay, I will clear my screen. So let's do something fun here. I am going to, let's say, add what's the index of, my row index and the call index. Let's just be simple here. And then I will do this. Boom. What does this function do? So for each time the for loop is run, you want to add the index of that row and the index of the column, and then populate it with the respective position. Is this clear? Okay, nice. All right, we will move on to Python functions. How many of you heard of the Fibonacci number? Like summing up the previous two variables and go on. If you've not heard of it, I'll just show it to you. So the formula is this Fibonacci number. So we have f of I is equal to f of I minus 1 plus f of I minus 2. Okay. Now I want to create a function. I have some good news though. Unlike Java or C++ where you have to do some annoying variable type declarations, Python, all you gotta do is this. Def, name your function, and the input variable you want to feed into the function, okay? And then don't forget a colon, of course. So obviously, I'm going to create an array, a dummy array for I in range n. So what this will do is populate the element 0 for n times. Are we clear with this? It's a very efficient way to like declare an array. And what we have to do is at the 0th index, we want this. So what this means is at the 0th index, I want that element to be 0. At index number 1, I want that element to be 1. Are we clear with this? And then what you got to do is for I in range, oopsies, 2, comma, n, f of I is equal to f of I minus 1 plus this f. Okay, here are some notes about for loops in Python. So when I say for I in range, this is the starting index, this is the ending index, and this is how much we want to increment. Okay? However, if I just simply say for I in range, let's say ending index, what this means is Python will automatically go from 0 to end index and increment by 1. Are we clear with this? And when I say for I in range, start index, end index, what this means is go from start index to end index. And obviously increment by 1. Now let's third one, the last one, for I in range, start index, end index, and then let's say increment index. We all know what this means, right? It's not going to increment the index by 1, but you can adjust it. Are we all clear with this? And also, if you want to work backwards, you might want to do something like this. What this will do is starting from the end index, it will decrement by -1 each time. Because let's say you want to go from index number 9 to 0, you want obviously decrease that index number, right? Okay. Yep, some good notes. And then obviously return. Let's say I want to return the value at the last index here. So yes?
Should be I minus 246.
Oh, sorry. Yeah. Good catch. You know, when you're doing programming, you're gonna make a lot of mistakes, just like I did. And thank you, Joey, for catching out. Okay. Okay. And then I will run this and let's see what the answer is. 8. 13. If you want to understand the math a bit, you can work it out with your hand. It's definitely fine. Take it easy. I know this can be a little intimidating, and also it's your first time using with Python, so it's okay. No worries. Also, another trick, you can actually return multiple functions in Python. How many of you taken CS 124, the intro to CS number 1? You know, in Java, like you can only return like a single variable, right? But in Python, you can actually return multiple variables. So when you're working with extremely complicated functions where you need to actually trace back all the data that you've stored in an arbitrary data structure, it's a good way to also create a function where you return like multiple variables. So I can give you an example. We'll do the same. Def fib is equal to of n is equal to, and then I'll just copy it. And then let's say I want to return the entire array. Because the first function, we're just returning what the answer is, right? But if we want to backtrace all the data that we've been storing, all you got to do is return the array and the last in it, like this. Put a comma here, okay? So first variable, comma, second variable. Okay? And then what we're gonna do is, let's say I'm going to call this, let's say fib new. All you're gonna do is, let's say n is 8, dp, I'll call this dp, and answer is equal to fib new n. And then let's print out dp, and let's also print out answer. Okay. Voila, you can actually return two variables at the same time using Python functions. So it's extremely comfortable, right? Okay. We'll move on. Just extra space, but I'll just get rid of it. Okay. How many of you heard of dictionaries or data frames in general? Or for those of you who took CS 124, let's say a hash map. Or do you remember that, or do you recall learning about hash maps here from CS 124? Okay. In Python, we usually refer hash maps as dictionaries. So what we'll do is, let's say I have an array. Let's say 0, 0, sorry. 0, comma 0, comma 0, comma 0, comma 1, comma 1, comma 1, comma 1, 2, comma 2, comma 2, comma 2, comma 3, comma 3, comma 3, comma 3. I want to figure out like how like many times each unique element in my list appears. Have you guys ever thought about like, okay, I'm given this like array. There's like let's say four different like unique elements, but they are repeated multiple times. I want to see like how many times they are appeared each time. What do you guys think would be a good idea? Do you want to really brute force and count each the number of times like they appear, or do you want to be more efficient here? Obviously, we want to be more efficient, right? Okay, well, let's first of all print out. Oh, I see repetition here. So what we're gonna do is I'm going to do this. Lewis dict dictionary. Or you can do this. Two ways, either way is fine. Either way is fine, honestly. But I'll just go like this. We'll declare a dictionary, and then let's create a function to count elements. Obviously, I need to give in a array list. Sorry, a list. Or let's just say my list. And obviously, I'll just create like a dictionary here, obviously, because we need to return a dictionary. And you can also do something like this for lm in my list. What this will do is it will go each element inside the list. For those of you who've programmed in Java, you guys remember what a for each loop is, right? Okay, for those of you who have not taken CS 124, a for each loop is just like pulling out the individual elements from that list. Are we all clear with this? Okay, and then all you gotta do, oopsies, all you gotta do is if lm not in Lewis dict, we're going to assign it as 1. Because what this is doing is like if this unique element is not inside my arbitrary dictionary I created, I'm going to give it a value of 1 to that particular variable, or to that particular element, I should say. But when I traverse through the list and I was like, hey, this element appeared more than once, or I already found this element. What should we do about it? Well, very simple. All you gotta do is Lewis dict element plus equal 1. And then return Lewis dict. And then answers, actually, let's just count lm Lewis. Boom. So what this means is 0 appears in my list 4 times. The element 1 appears in my list 4 times. And obviously 2, 3, yeah, respectively 4 times. Are we all clear with this? So whenever someone asks you like, hey, I have this list, I have a certain item and I want to like see how many number of times this item appears. Can you write me a code for that? This is how you do it. Are we all clear? Okay. And also, we're going to be creating data frames. Data frames is extremely important when you're trying to like store like multiple informations or some crucial data. So if that's the case, what we do is we'll say df is equal to this, and then we'll go like curly braces like this, curly brackets. Then we'll do like student, and then we'll say Lewis, Anish, Alex, Jay, and Ethan, Christian, Avi, and then Hugo, Hugh. And we want to store each major, so civil engineering, CS, CS, Compy, another CE, aerospace, electrical engineering, mechanical engineering, and we have another CS major. Okay, and then minor, say CS, nothing. Physics, CS, 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 and then EE.
Yes, it is.
Yeah, and what you can do is shift, boom. There we go. You need some more time filling in? I can stop. Yeah. Sure.
For dictionary, for example, up there, you have 0, we have 4, 1, we have 4, etc., etc. But if we want to sort it by our key, like if my key is like we first have 1, then we count it to 3, and then we have 2, can we sort this?
You can actually sort by the lambda function for the dictionaries you just created. You could either do this by sorting by the keys, or you can sort them by the items. So in this case, I will show you how to sort them by the keys. So my keys is equal to list of we'll say, sorry. We'll just store this count element as answers. And then all we gotta do is let's double check what our answers are. So as you can see, this is what we have. What we can do is we're going to then sort by keys first. So my keys is equal to list of answers dot keys. Obviously, we're going to sort by keys. And we're going to call the sort function my keys dot sort. And then once we've sorted that, we're going to say sorted dict is equal to I answers I or I and my keys. And then we're going to print sorted dict. As you can see, the keys are sorted in order. And yeah, you can see the respective value for each key. Now, I could sort by items. So what I'll do is I'll create another variable, sorted answers is equal to sorted, and then answers dot items, and then key is equal to lambda x of 1, and then I'll just, for the sake of simplicity, just say this. There we go. So as you can see here, we've sorted this by items, and we can literally see like the increment, as you can see here for this one, it's all 4, but let's say I'll add another 0, 0, 1, and then let's take out the 2 here. Let's just say this. Call this one more time. And then if we say this one once again, oopsies, sorry. Let's rerun this one once again. There we go. As you can see, the items are sorted in ascending order. So for the updated list here, I've adjusted the number of zeros, ones, twos, and threes. As you can see here clearly now, we can see that it's clearly different how we sort. The first one, we can see that it's sorted by keys, and the second one is sorted by the items. So yeah, definitely keep a note of this. It's a very important function. Okay, and then if we want to convert this to like data frame, like let's say like a CSV, all you got to do is create df store data is equal to, oops. Don't forget to import pandas as PD. PD.data frame. Df, and then store data dot to CSV. Let's say store data dot CSV. There we go. Um, if you're using this in your local terminal, you can do this, and then like inside your folder where you're using this notebook, a file will be created. Do you guys understand? Okay. And then because like we're using Google Colab here, what I'm going to do is like this is the reading function. What we're going to do is import numpy as np, import oopsies, pd. And then these are the two variables we're gonna need, obviously. And how many of you are using Google Colab? Okay. Do this from google.colab import drive, and then drive.mount content drive. Okay, and then you need to specify your path. Obviously, I am using ITE UIUC. Okay. You'll see this. All you gotta do is connect to drive. And then, boom. Yeah, and you'll see allow. Are we all clear with this? It's gonna take a little while. Okay, mounted. Oopsies. Just out of it. And what we gotta do is we've already specified a path, and I want to extract the data that I just created. So path plus students dot CSV. And then let's say I want to read what the data I have. So all you got to do is pd dot read CSV and then students. So df. What the heck did I just do? Read CSV students. Hold on. There is an error. Please. Oh, my bad. There we go. When you're like, okay, another important thing here. When you're mounting this on Drive, you need to make sure that slash is like put into place when you're actually creating a path, because like what the how the computer does is like it will go, the slash is like the way to like go through. So it will go through the content drive, and then it will go to your My Drive, and then it will go to the folder that you have saved all your code, all your data sets whatsoever. And then it will go to that data set, and then inside there, I save my students.csv here. So this is how it works here. Are we all clear with this? Okay, thank you. And okay. And let's say I want to extract the first 10 elements. All you got to do is I'm going to go like this. Boom. I think the reason why like it's cutting up to 8 is because like we don't have like up to 10, but if you, let's say, want to extract the first 6, you can do like this. If you don't put any parameters inside the head, it will just like by default like give out a couple of first couple of values, and that's it. But it's better to like specify how many like first elements you want to see. And obviously, if you'll notice that there is an unnamed here, right? If you don't want to see that, all you got to do is just say index call is equal to 0. There we go. Don't forget to add index call is equal to 0. Okay? Because I know Python can be a little weird with data sets and stuff, so it's like that. But yeah, anyways. And I want to count the number of civil engineering majors. Okay? So how do we do that? Well, here, all you got to do is df major is equal to CE. And then I want to count. And then I also want to see what the values are. So let's do this. 2. So basically there are 2 civil engineering majors, myself and Ethan. Now we want to count the number of CS majors. So we'll just copy this code. rename it to CS, 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 okay? And then 3. So as you can see in our data frame, Anish, Alex, and who else? Yug are the CS majors. So there we go. Are we clear? Okay. And now we're going to do some plotting. Oh yeah. Let me thought. Hold on. So CS major and CS minor, right? Okay. Okay. So if we want to count the number of C majors and CS minors, all you gotta do is you need to apply the double conditions. So let's write down double conditions. CEE CS is equal to DF, and then don't forget this, DF major is equal to CEE, and DF of minor is equal to CS. Now let's check this out. There we go. So myself and Ethan are the ones who are majoring in civil engineering and minoring in CS. Also, if we want to count the number of civil engineering students majoring in civil engineering students minoring in CS, all you got to do is call the count function, and then we want the values 2. There we go. We'll move on to plotting in Python, and what we'll do is we'll do this and then import matplotlib.pyplot as plt. Okay. And then for those of you using Google Colab, we'll do this again. Just copy this all the way down here. Okay. And we'll say high speed. Oopsies. High speed train. Oopsies. Speed. We're going to be comparing the high-speed trains, the maximum speed, maximum operating speed of the high-speed trains around the world. Okay. And then data obviously is pd.read Excel. And then high-speed data. Oh, sorry. It should be. There we go. I know I went a little fast here, but if you guys need some time to copy this code, yeah, feel free to interrupt. It's fine. Are we all good or good? Okay. And then data.keys. Let's see, like the reason why I particularly wanted to like print out my keys is because like I want to see like what columns that we're going to be using to analyze the data. And if we want to find out the mean maximum speed, what we do is data max speed boom, and then dot mean. So we'll print mean max. Okay. So basically the mean maximum speed is like 342 kilometers per hour according to our data set. And if we want to use the median maximum speed, what we have to do is max speed. We'll just do this. And then dot median. So our median max speed is like 320 kilometers per hour. And we'll also compute the standard deviation. Print. So 53.995 kilometers per hour. And variance, we'll also compute the variance if you guys want. So we'll just save our. Yeah. So variance is obviously the standard deviation squared. Okay. And then we could do like a box plot. So data dot. And let's say we want to see the title. So plt dot title, high speed train speed, plt dot x label category. Boom. We can see a box plot here. You might use this if you're taking like a data science class like Stat 107 or CS 357 or possibly C 201. It's also a good function to have, definitely to visualize and understand some data. Okay. And if we want a bar chart, a horizontal display, what we're gonna do is we're gonna say train names, data, and speeds is equal to data, max speed. Oopsies. Because we're going to get we first want to like get the x-axis, which is the train names, and speed will be on the y-axis. Okay. And what we'll do is we'll plot the bar chart, plt dots bar, and we're going to oopsies, we're going to say train names and speeds, plt dot x label. And then obviously plt.title, high-speed trains. Then just say plt. Let's see. There we go. How does this look? And if we want to do like a vertical display, all you got to do is copy all of this we're going to be using the same data. Okay. And then instead of plt.bar, we're going to add h. And then obviously vertical. You'll notice that I actually put this plt.savefig. If any of your like professors or your TA says, oh, when you submit your programming assignment, you need to include the plots. What you have to do is call the function plt.savefig and name your file. So obviously my figure name is vertical plots here and then .png because I want to save my plot as a PNG image of the plots. Are we all clear with this?
If you change the dot, if that one change dot JDB, will actually change it.
Yeah. But mostly like I would prefer using .png.
Yeah.
Yeah. Also, another useful function here using NumPy is x is equal to linspace. So let's say I want to create like a list or like an array, let's say from 0 to 100. And also let's space out between like let's say approximately like 10. What we can do is here. So I'll tell you what this is. So start number is 0, end number is 100, and how much, the last part is how much we want to space out. Okay, if I print this, there we go. I know it's not exactly like 10, but as you can see here, we're kind of like spacing out a bit, like, you know, approximately 10 different like elements here. So yeah, that's what you can do. And then I want to plot a linear function. So what I could do is def linear. We obviously need the slope, x, b. And then y is equal to mx plus b, return y. Okay? And then m is equal to 2, b is equal to 5, and y is equal to linear m comma x comma 2. And what this will return is voila, y equals mx plus b. And then you want to store it as an array and you want to see what the variables are. Okay? And if we want to plot this as a function, we can say equation is equal to y equals, don't forget, oopsies, don't forget to convert all your numeric values into string. And then this. Okay. And then we'll plot this. What the label will do is label that curve. And also, if you're going to label curves, don't forget to call the legend, okay? There we go. So we can see a legend here, right? Are we all clear with this? Okay. Since we're kind of running out of time, this trajectory curve plotting, it's just like for you guys to practice. I will definitely post the solutions online as well. If you guys know all of this, then you should be more than well prepared to follow any like plotting stuff. If you guys need help with this KTX trajectory curve plotting, just please email me or please message me on Discord. I'm definitely willing to help. I know we're kind of short in time, so I'll be talking about the math you guys have to know for working with your classes. Would that be okay with you? Okay. So, calculus. How many of you take Calc 2 or physics? Yep. We all suffered through calculus, right? Oh my. And guess what? TAM classes, they're gonna ask you for all the calc stuff again. Oh dear. Okay, don't worry. If you want to work with calculus, there's a very important library I recommend you guys using. So, from SymPy, import star. Okay? Now, obviously, we want to take the derivative with respect to that variable, t, right? Or x or whatever. So what we're going to do is t is equal to symbols. Okay? There we go. Does this work? And we're going to compute the derivatives. So obviously, we know the displacement function. So VI is equal to 5 meters per second. A is equal to 10 meters per second squared. X is equal to VIT plus 0.5 times A t squared. Okay, let's print this out. Okay, and then I want to calculate the velocity. I want to find the formula for velocity. Obviously, velocity is dx dt. So what we're gonna do is diff x comma t. Boom. So 10t plus 5. And then I want to compute the acceleration. So A is equal to diff v comma t. Okay. We all know the derivatives and we've all taken physics, right? Okay, so that. Now we're going to compute the displacement, velocity, and acceleration when t is equal to 3. We're given a numeric parameter here. So what we're going to do is we're going to use a lambdify function. So x answer is equal to lambdify, and then t comma x, because we want to make sure that x function can also input a numeric value t, not just like, an arbitrary variable t. So that's why we're calling the lambdify here. So ti is equal to 3 and x ands, oopsies, ti. There we go, 60. We'll do the same again for v. And then v ands is ti 35, and then a ands equal to, obviously, there we go. Oh, actually, never mind. We're already given. Oh yeah. There we go. There we go. Sorry. Okay. Another important thing. Once you lambdify your function, always use this, and then input the numerical value inside. Okay. If you guys have any questions, please interrupt. If you don't understand, just let me know. Good. Okay. And we can also use some trigonometry stuff. You're definitely gonna have to remember your trig stuff from TAM, obviously. So we'll do An example in trig, symbols, theta. F is equal to sine theta. So F sine theta. And then obviously, if you want to take the derivative of it, all you got to do is just call this, then say df. Oh, whoopsies. df is, huh. Oh, my bad. There we go. Sorry. So I did df slash is equal to diff of f, and then it'll take the derivative of the sine. And let's say when also notice guys, when you're using with trigonometry, make sure all the degrees are converted into radians, because like when you're doing like when you're solving like system of equations, or like when you draw like free body diagrams, and then let's say an angle is given to you, let's say 30 degrees or 60 degrees, key piece of advice is like convert the 30 degrees into radians, so 30 times pi over 180. Are we all clear with this?
Simply and numpy for radian or degrees?
Radians.
Radian.
It's radians. It's I remember for 10 to 12, the dynamics class you guys are gonna take after 210, the TA actually said make sure when you're dealing with the trig, and if let's say a degree is given, just convert that into radians. We all know how to do this, right? 30 degrees times pi over 180, you get the radians.
For simplex do that because I know we have all the numpy.
I just like, because I just like use like, if data is given to you, just don't overcomplicate yourself. Just okay, just write this down. Theta, and then theta equals pi, theta times pi over 180. That's how I would do in like my TAM quiz. Because like, guys, you're only given 50 minutes to complete the quiz, okay? And we're drawing all this free body diagram, yeah, it's a pain. Okay. Already so really happy. Okay. And yeah, let's also continue on here. df lambda by data, and then df this, and then a is equal to df np dot pi over 4, and then a. There we go. So what I just did is like I lambdified the function, so the derivative I got, and then I inputted theta as pi over 4, because we want to see what the cosine of pi over 4 is. So this is how we would do it. Okay. And partial differentiation. How many of you are taking Calc 3, Math 241? Okay. Bad news, you're gonna have to deal with a lot of this. Okay, so we have here, so x comma y is equal to symbols x comma y, and f is equal to this, and then part x is equal to diff boom. There we go. That's the partial derivative with respect to x, okay? And if we want to do partial derivative with respect to y, we'll go like this. Boom, 2y. And single integration, we will do something like this. If we want to integrate, let's say a function with respect to t, and also we're giving the boundary conditions here. This is what I would do. Let's initialize all the variables. Vi is equal to 5, a is equal to 2, and ti is equal to 0, and tf is equal to 5. Okay, and t obviously is a symbol here because that's what we're trying to integrate with respect to. So whenever like let's say you're given like a dt or like a variable that you want to differentiate respect to or like integrate with respect to, that's when you call the symbols function in SymPy. And what we do is vf is equal to vf t vf is that. And then we're going to integrate with respect to t, so delta, we'll just say delta x is equal to integrate, and then vf comma t. And then what's our delta x? T squared plus 5t, okay? And then since we're given the boundaries in this case, obviously we're going to have to lambdify our results here. So what happens is what you're going to do is vf results is equal to lambdify. I want to lambdify my vf function here. Please. And then what I'll do here is I'm going to integrate with respect to a t. So obviously I need my results for the vf. And I also need to do t comma ti tf and then delta x. There we go. So 50. Are we all clear with this? Actually, you don't need this. Sorry. So what this does is like when you're integrating, if you look at this tuple inside here, make sure you feed in like the variable that you're trying to integrate respect to, and then give it the beginning and the ending conditions with respect to it, and then you'll get the answer. Okay. Since we're a little short in time, we'll do some double integration. I know this is a little weird here. What we're going to do is we're going to do a double integration of this. Okay. So what we'll do is we're going to obviously set up our boundaries. So also a b is this. Sorry, let me just. This is a. Great. This is a. This is b. And this is c. And this is d. Okay. Sorry, this LaTeX thing has got some errors here. I don't know why, but you get the big picture here, right? Yeah, I tried doing that, but it didn't seem working. We're sorry about the inconvenience, but you can take a picture of this if you need to. Or I can also take a picture if you need. Also, what we're gonna do is a is equal to 2, b is equal to 5. Always set up your initial conditions, c is equal to 1, and d is equal to 3. And then x comma y is equal to symbols. And let's print out the two variables here, x, y. And then, yeah, we have a function f. Okay. And delta x is equal to integrate we're going to first integrate with respect to y, because sorry, we're going to integrate with respect to x first here. My bad here. So it should be XAB. Integrate respect to source. As you can see here, because like in the inside, we're integrating with respect to dx first. Once we've done that, we're going to integrate with respect to y. So delta y is equal to integrate there we go. Are we all clear? And some linear algebra here. You'll probably need some like you'll probably need like the three libraries: import numpy as np and import numpy.linalg as la. You'll definitely need a lot of these libraries when you're solving like homework problems or when you're doing lab for math 257, and obviously the TAM classes, and also C 201 if you're taking it. Also we could also use SymPy as well. Okay. These are the three libraries I think you'll probably most likely gonna need for linear algebra. Numpy as NP, numpy.linalg as LA from SymPy. Obviously, it's always good to have if we're working with math. Okay. Okay. And let's say we have a matrix here. So what we're gonna do is A is equal to np.array 1, 2, and then 1, 0. And answer is equal to 2 times A. There we go. So it's just scalar multiplication, so it's pretty easy. Now, we want to do a dot product here, matrix dot product. How many of you guys have heard about the dot product? Are we all comfortable, or do you want me to explain the math here? Okay, I guess if we're all comfortable, I'll just talk. So obviously, we're given this matrix A here, so I'll just say this. V is equal to np dot array 1, 2. And then what we're going to do is AV is equal to np dot A, V. Okay. So what this does is, so if we have matrix here, and I have this. So 1 times 1 plus 2 times 2, 1 times 1 plus 0 times 2 is equal to 5, 1. Okay, are we all clear? Okay, nice. You can try this on your own. It's pretty much same. And we're going to use some cross product here. If you're in Calc 3 right now, you're definitely gonna have to use a lot of this as well. Cross product, very handy tool. So what we're going to do is vector 1 is np.array 1, 2, 3. Vector 2 is np dot array 4, 5, 6. And then we're going to do like a cross product of vector 1, vector 2. And by the way, order matters in cross product because obviously, you know that cross product form that we've learned from Calc 3, right? Are we all comfortable with this? Okay. We'll also be solving matrices. Um, if you know how to, let's say like you're doing homework for Math 257, and let's say, oh, I'm too lazy. Oh, this calculation. Oh, I want to double check my discussion, blah, blah, whatsoever. I'll give you some advice. Just do this for me. All you gotta do is np.array 1, 2, 1, 0. Let's do this. 3, 5. Okay? And then I want to find the solution. So what you're gonna do is la.solve a comma b. And then once you do that, you get the solution 5, -1. Okay? So let's say like you're given like a bunch of homework problem sets and you want to like try running this on your computer, or you want to check if your calculations are correct. Here's a handy code. Just do this for me and you'll realize what mistakes you've done, or you'll definitely realize like what computations that you've done wrong, or like what needs to be done. But I think from my knowledge, when you take Math 257, you're not allowed to use Python, right? When you're solving the exams. Is this right or no? Okay. If that's not allowed, then if you can't use Python, or if you can't like use this to like pick the multiple choice answers, just keep it as a reference. Whenever you have to study for your exams, it's a good way to run the Python to check, whether you've made certain mistakes or not. Okay. Okay. 10 people, listen up, because you're going to be using a lot of this next week quiz. Okay. So what we're going to do is we're going to convert all these three variables. Okay. Now, because there are so many variables here, I'm going to just create like an arbitrary list here, like this. And great, I cannot spell. Symbols, and then variables. X, Y, Z. Okay? X, Y, Z. And as you can see here, you could do la.solve, but this might be a more like efficient approach when you literally have no time to solve your TAM quiz. Let's go like this. B1 is equal to 10, B2 is equal to 2, B3 is equal to 3. Okay? Now combine the equations. Okay. What we're going to do is I'm going to like shift all of this to the left. So on the right side, we all have 0. So what I mean is you're given this, right? What you want to do is you want to shift all of this to the left, like this. You want to put this format inside your computer code, okay? So you basically don't want the equals here. So just put everything to the left, okay? Are we clear? And oops. what we're going to do is we're going to combine the equations. Ik1 is equal to 2 times x plus 3 times y plus z minus b1. Equation 2 is equal to 4 times x minus y plus z minus b2. Ik3 is equal to 3 times x plus y minus z minus b3. Okay? And then we're going to combine all the equations together into an arbitrary data structure like this. And then let's print out the equations for the sake of convenience. All right. Boom. So basically, what Python has done is like we've stored like a variable of equations here in like a list. So basically, we have like 3 equations in a list, and I'm going to call the solver. So solutions is equal to solve equations and variables. Boom, there we go. And if you want to convert all of this into floating points, because I'm pretty sure you want to see like what these values are, all you got to do is solutions x, okay, and then do the same thing for everything else. Okay. I know it's a little annoying here, but make sure you have this float, okay? Float is like floating point, so you can see all the decimals. That's how you can remember. We're going to move on to eigenvectors. Eigenvectors are it's this, if you haven't taken linear algebra, it's just this. Eigenvalue is the lambda, eigenvector is the vectors that corresponds to each lambda. So yeah. So we'll create a matrix here. And I want to get the eigenvalues. la.eig. As you can see, like the first array is the eigenvalues, and the second output I have, that's the eigenvector. Are we all clear with this? The first one is eigenvalues. The second one is eigenvectors. Okay, so basically, if I want to get the eigenvalues, then I would just print out this. Give me the eigenvalues. There we go. Now I want the eigenvectors corresponding to that. Boom, there we go. Are we all clear with this? You'll definitely cover this more in your Math 257 class, so I wouldn't worry too much about it. As you know how to like the important thing is like that you know that there are functions in Python where you can do this. And okay. How many of you are in C201? Yep. Your best friend. This guy is gonna definitely come up. So if that's the case, what we're going to do is from scipy dot optimize import linprog. Now, our objective function is to minimize anything that has the word minimize or maximize. That is your objective function. Okay. So what we're going to do is c is equal to -2 comma -3 because it's -2x negative 3y minus 3y. Sorry. And then we're going to call the coefficients. So basically the subject 2. And I'm going to create a 2D array here. 1, 1, 1, -2, -1, 1. Okay. And then what we're going to do is I'm also going to create my right-hand bounds. So 5, 2, 3. It's like, here's a thing. Anything to the left, make sure you store it as like a 2D array. Okay? Don't do any NumPy, whatever, just a 2D array is fine, okay? And then we also need to find the x bounds. So x bounds is equal to 0, none. Y bounds is equal to 0, none as well. And then what we're going to do is call the function linprog. And then we're going to call the constraint. So basically the coefficients for the objective function. Then a ub is equal to the a. B ub is equal to b. And then bounds obviously is going to be our x bounds and then our y bounds. Okay? And so basically, if you see the message optimization terminated successfully, you'll see a success is equal to true. And the x values are the ones that you would want to refer to. So because this is true, I'm going to also print out the x. Okay? I will also first print out result. If success, then go ahead and print out. Okay? Are we all clear with this? Now we want to maximize this, right? So if this is the case, we're going to do the same. C is equal to 1, 2. But we're going to actually like negate this because the SciPy linprog is built in for like minimization problems, but obviously you're gonna have to do some maximization stuff as well. So what we're going to do is I'm going to flip the coefficients of the objective function, so it will become like -1, -2. Or you can do something like you can either do this when you're flipping around, or if you have too many variables, just do this. C is equal to -I for I and C. Okay? And then do the same thing. We're going to create like a 2D array, -1, 1, 2, 2. Okay? And then what we're going to do is B is equal to 1, 6. And then x bounds is obviously 0, none. Bounds is equal to 0, none. And then you know the drill, right? You know the drill, right? And then let's check if, okay, termination is true. And then I'll print out x. 1, 2. That's the function that maximizes this case. Are we all clear? Okay. And just a quick note, I'll probably skip probability and statistics here. Any of you guys are taking CS 361 by any chance? Because most of the like probability and stats class that I am aware of uses like it's either going to be just pencil and paper or like tiny bits of R. But if you guys want me to teach you how to use Python using probability and stats, I'm more than welcome to do it, but we'll do it at a different time. Because these are the stuff that you pretty much have to use, and the remaining parts are kind of optional. So yeah. I could teach you, and also the next one is classes and objects. This is definitely going to be important when you're gonna have to deal with like personal projects or like group projects, or when you have to like store kind of large set of data and do some like calling multiple functions. I will cover that and then we'll end our tutorial session here. Will that be okay with you guys? Okay. All right. Final set. Yeah, just weird stuff here. So, how many of you have rode a high-speed train before? Pretty much everyone here, right? High-speed train. Yeah. Or if you've never, that's fine. I'm gonna be talking about the Korean high-speed train, KTX. So, obviously, like, if you're going to do some object-oriented programming, you're gonna need classes and objects. How many of you have taken SE 101 or will be taking SE 101? You know what a blueprint is, right? Yep. In computer science, you call them classes. And then inside a blueprint, what do you have? You have all the details and all the stuff that you need to draw, right? Those are called objects in computer science. So we'll create like a blueprint for our high-speed train KTX. So I will say class. I will zoom in. KTX. This is a blueprint, okay? And def init self model, and we have a train number, obviously, max speed, operator, here, electricity, and how many cars it can store. So what this init does is like when you initialize the class or the object, you want to give it in some like input parameters, right? So if that's the case, make sure you have self because you're trying to initialize yourself. And then like after the self, you can call in the input parameters that you want to initialize. So self dot model is equal to model self dot number. Oopsies. Self dot max speed is equal to max speed. And self dot cars is equal to cars, and self dot stations. Because I'm not given in like the train stations here, I'm going to just initialize as an empty list. And I want to set speed. Don't forget to call self here, new speed, and then self dot max speed. When you took like CS 101 or 124, did you guys learn about like setters and getters? When you have functions like setters are like when you're given an input parameter, you want to update that, and getters is just retrieving that specific variable. Are we clear with that? Or okay. And then get speed, self. All you got to do is return self dot max speed. And def set stations, obviously. We'll give in like the stations that this train has to stop. dot stations. Return. Okay. Boom. So this is what it does. And then we're going to create like an object here. So model is KTX1. It's that TGV style KTX. And number is 123. Max speed, let's say 305, 330, or whatever. And operator is CoRail year 2004. That was first made. Electricity is 25 kilovolts. Any of you taken C412 high-speed train engineering? Yep. You'll know this. Guys, if you need like a 400 level, like a fun class, C412 high-speed rail engineering is a class I recommend. And if you're studying transportation like me, it's a must-do class. Okay, guys?
One comment about that class, though, it's kind of like, I'll say it's geared towards train enthusiasts, so you definitely do not need to have have a lot of knowledge on trains to be successful in that class. Just think most people that take that class are indeed train enthusiasts.
Yep. And let's see. Oh, oopsies. We'll just say 305. Okay, so we've already created like an object here. Now I want to get the max speed. What is the max speed I have just declared right now? What I'll do is get speed. There we go. 305 kilometers per hour. That is the maximum operating speed of all high-speed trains in South Korea on a dedicated high-speed lane portion. And let's say the Minister of Transportation decides to upgrade the operating speed to, let's say, 330. Then what we can do is 330 and then KTX1 dot set speed of speed. And then let's also get the speed. Okay.
Basically, get underscore is get any data, and then whatever is after the underscore is the data you're trying to get.
Yeah. And then let's say I want this train to stop at the following stations. 서울, 대전, 동대구, Busan. And then I want to say KTX1 dot set stations. And then I want to get the stations. Like I want to figure out whether if these stations are right. There we go.